Alrighty, captains. Today, what we have is a wire patch that actually splits our composition up into an 8x4 grid. And every time we click this shuffle tiles button down here, it's going to shuffle our tiles. So what we also have is some extra parameters. We have a shuffle duration, which can go up to 4 seconds. So basically that'll be how long it takes to shuffle these around. By default, it's 1. We also have a shrink amount, which we can put down to 0.75, which will mean these tiles shrink down a lot. Or we can put them all the way up to 0, which means that they don't shrink at all. Again, this is set to 0.25 by default. The bottom boolean down here is a round tiles. So what happens if we click this, our tiles will actually turn into little circles as they're moving around. So this can be just a little bit smoother and nicer if you're doing something like a rotating around some photos, or just want a slightly different look, and that can be taken off. So again, if you really wanted to make it like more on sync, we can come in, just BPM sync this. So every 4 beats, we're going to have this shuffle. And again, same thing with the parameters for the duration and the rounding. So put this back to none. The way this is built is it looks at the composition width and height. So if we come in here and say 3840, apply, it will stretch to the correct aspect ratio. And it will keep shuffling away. The reason this can't, I don't have these exposed values at the moment is in Wire, the grid pattern doesn't have the inputs exposed. You have to manually set that inside the block. So let's jump into Wire and see how this all works. So here is the patch in Wire. Again, I'm just going to enable shuffle here. And whenever I click the trigger in, we are going to reshuffle our test card. Our test card isn't super interesting, so we're going to put another texture in by default. So here we come in. I'm using a hub here. Now, if you're not familiar with hubs inside of Resolume Wire, if you go right click and go into your logic, you can bring out a hub. Now, hubs function very similar to nulls in Touch Designer and in Notch. So if you're used to that workflow where you'd run something into a null first and then run everything out of that null, hubs work that way. Now, I've used quite a few of them in here. So at the moment, I'm using a texture in, which is defaulting to our test card. And this is how we'll have it set up for when we compile our block. But just so it's easy to see inside of Wire here, I'm actually going to use this video I've dragged in, which is the same falling icosphere. We could also, inside the test card, pull in the live feed from Arena, but I'm just going to run it this way. So a broad overview of what happens. And then again, this is very broad. We'll go into details. So we have the video feed coming in. We are getting a grid system made down here. That grid is then looking for a mask. So it's basically taking one certain section. Let's just take the shuffle off. So look for whatever section it is, and it is going to crop in and mask out that one position. We're then going to recorrect for the position of where that needs to be. So we're going to basically say that's a 0, 0 there. And then we're going to come in and put a shuffle on it. So when we come in here and shuffle it around, it moves it all around. And then we're going into an output. So quite a bit to go over here. Let's try and break that down. So to set how many width and height we've got here, we actually have a grid pattern node. Now this is basically what's going to determine where we put our instanced tiles. Now inside this grid pattern, you can see we have rows set to 4, which is actually our Y, and our columns set to 8, which is our X. And unfortunately, these aren't accessible. So if we actually came in here and said visibility, we can't actually access the 4 and the 8, which would be great. We could make this completely modifiable inside of Arena if that was the case, but we can't right now. So because of that, we have over on this side, it's a bit hard to see with the color. We have a tiles X and a tiles Y integer. So here I've set the tiles X to be 8. And if we come back and check our grid pattern, we have our column set to 8. And our tiles Y, come back in, is set to 4. And in here, our rows are set to 4. So what we're going to do is basically say, we're going to use these values over here that we've made to do all the math to make sure that our tiles will say the correct size as long as it's 8 by 4. What we've also done is we've grabbed a patch info node. And what this allows us to do is grab the name of the event we're running, the patch resolution. So what size we're actually running it inside of Arena. That's when you saw before when I scaled it up to double wide, it scaled with it. We can also get our aspect ratio and the bit depth, but we're really only interested in the resolution and the aspect ratio. So let's kind of start right back at the start. We need to make a bunch of rectangles, and we're going to use those to mask a bunch of sections of the screen. Now, if you followed along with the instancing tutorial in the Wire official Resolume YouTube page, you may have seen something that looks fairly similar to this, where the tutorial leader actually went and put a bunch of objects on a grid and then used them to shuffle them around. What we've done here is very similar to that, but we've now added a video texture that stays locked to each one of these as they move around. So if we slow this down, this particular tile in the top left, the texture actually stays locked to it through its entire motion. Otherwise, it'll just be a mask showing the same thing. So how do we get the individual tile sizes? What we've done first is coming across down here. We've used a 1/x node. Now what this will do is divide 1 by whatever value we feed into it. And because we've got 8 tiles across, one of these will be 1/8 of the whole resolution. So what we're coming in here is saying we're taking this tiles x, which is 8. 1 divided by 8 is 0.125. We're running that into a multiply node. And we're then multiplying that by the aspect ratio, which is 16 divided by 9, essentially. Now, the way I'm doing this is because I'm treating the height to be 1 unit, but the width is going to be variable based on the aspect ratio. So we get out of that a 0.22 recurring size for width. Now, the height you can see here is just 0.25 because there is 4 high. We just basically grab our 4, 1 divided by 4 is 0.25, and run that straight in. Again, we're only modulating the x size by the aspect ratio, and we're leaving the y unit to be assumed as 1 high. Okay, so once we feed out of there, we are going to be jumping into our select regions per tile and mask. Now, this part here, if we remove it, is basically just going to be saying we want to grab each one of these rectangles, because we've now made 32 of them, and we need to move them to wherever the new positions sort of are, the grid position in Y. So you'll see here, if we look on the edge, because there is an 8 by 4 grid, there are 32 positions, and each one of those has an X and a Y coordinate. And these will count up. So all the way from negative, all the way through to 7.5. All right. Now, how do we get this number? This is a little trickier. So we've actually come in and we've used another couple of hubs down here. So this hub aspect ratio is basically just grabbing a line from here, the hubs tile X and hubs tile Y. So what we're doing now is we are getting our aspect ratio here, which is 1.77. We're dividing that by how many tiles we have in each direction. So it's 8. We're bringing that across. But because if we did this normally, you would see that these overhang. We want them to be centered in the middle. We actually, let me just adjust for this. Here we go. Because they're spawned in the middle here, so the center spawn is actually half units in, we need to come and say, all right, we want to do this version number up here, but we want to divide it by 1 less than the width here. So we're basically saying how many units in X, we're going to subtract 1 and divide it by that. So we have our 0.22 here, and we're dividing that by 7 and, multiplying that by 7. And that's when we get how wide this grid unit system needs to be. So the whole grid is 1.55 recurring in X, and we're doing the similar thing in Y. But again, because we're not worried about the aspect ratio in Y, all we're doing is saying how many units are there in height. We're taking 1, so we're doing the 3 divided by 4, and that gets us our 0.75. So our grid is 8 columns wide, and it is 1.55 recurring units wide, and it is 4 rows high, and it is 0.75 units high. So this point here to that point there is 0.75. This point here to this point here is 1.55. Alrighty, a little bit of confusing maths, but when you run it, it works out. Okay, so now we've got that, we're running it into our grid. So we have each one of these tiles is instanced onto that grid. So there are 32 of those. Now we're not moving these around or doing anything fancy with them yet. We're just basically placing them on the grid, and we're using the output of this as a mask for our input texture. So again, our texture is coming in into the top of a mask node, and we're masking it just with this move. So each individual one has its own mask and has its own rectangle. So, alrighty. Next, we're going to be doing a few other parts down here for the shuffle, and that shuffle is then going to come in to a set new position. So let's now jump back a few nodes. So what we have here in our grid is our grid here is now going to feed into our shuffle on off gate. Now what's going to happen down here is if I come in and reshuffle, it's going to be a bit hard to see because we're not looking at the end node. So let's go into smooth nodes and end. Put that on. So if I come in here and I reshuffle, you'll see all of these will start moving around to a different position. What the shuffle node here does is it basically looks at where all the positions are of our instanced rectangles. And when I hit this button, it will randomly pick a new position for each of those rectangles. At the moment, I've got it set so that it doesn't overlap. You can have it set to duplicates, and if that happens, multiple tiles can be in the same place at once, but we do not want that to happen for this effect. So we take duplicates off. So whenever this reshuffle happens, this reshuffle is then running into a gate, and that's just basically down here in our inputs. We have the option to say, we don't want it to shuffle. So at that point, even if you click on the trigger, it won't shuffle at all. So both the trigger in and the enable shuffle are down here in our input section, along with our duration, amount, and our rounding. So if the gate is set to true, because that boolean is on, whenever that shuffle button is hit, it will reshuffle things. So let's just make that back to true so we can see it. We also have a hub smooth duration. So again, from back down here in our input, we're just using a hub here to make it cleaner. And we're running all of this into a smooth node, and however many seconds we have is smoothing that out. So again, clicking trigger, the 4 there is what's happening. Okay, so what we're doing here is a little bit different. We need to subtract and do some math to get these positions back where they need to be. Otherwise, we're going to be adding this offset, which is all the way from 0, and we're going to remove this around. It might appear off screen. So we need to sort of negate where it is. So we're taking our new position from our smooth, and we're actually going to do a subtract node, and we're going to subtract its original position in the grid. So here you can see this grid pattern is all of the original positions of all of our tiles. And this new smooth is all of the newer positions where they're supposed to go to. And as you can see, they're very different. If I take the enable shuffle off, you should see that the first one is 1.5, 0.75, and it will eventually settle back in its original position. So we need to take this new value and subtract its original value to get where it needs to go. And that's just happening up here in the subtract. And we'll deal with this next section later. We're also grabbing a hub from our resolution, a hub from our aspect ratio, and a hub from our tiles Y. So what we're doing here is we're saying, all right, what are we doing for our divide? So we're basically grabbing our resolution and we're dividing it by where all of these sections need to be, because we need to convert them from screen space, which is -1 to 1, or a 0 to 1. And then we need to convert that into pixel space, which is resolution. So that's going to be 1920 by 1080. And then down here in the pack, we're also going to need to do another resolution check, which is going to be how wide versus how high each of these parts are. And they're going to come into a pack. That pack is then going to go into a further divide. So we basically got the new pixel resolutions, and we're going to divide them by values that bring them back in line to where they need to be. This transform here is actually what moves these individual pixels around, these individual panels around. So trigger in, comes in, we take our transform. The new scale is based off of the shrink amount. So if we drop that all the way down, you can see that scale changes here. If we move it all the way to 0, we click it, it's just going to stay 1, 1. So we coming in here, the translation is actually what's moving. And you'll see here, it's taking a while to reset itself back to settle down. And that's just because the smooth node takes a long time to settle. So once we've grabbed an individual tile, we've reset it to where it needs to be, and we've shuffled its position and it's moved around, we can then run this again into a hub. Think of this as a video null, and then out through the texture output. So again, let's just set this to something like minus 0.25. Let's set this to 1. And now every time I trigger, we're going to have this shuffle effect looking. If I turn the round tiles on, we'll make this circular look. I don't think I've covered that, so let's just jump back into the graph. So the round tiles, are actually coming off this section down the bottom here. So I have an attack release, and this is originally set up so we can handle the scaling. So you'll find down here the shrink amount and the shrink duration feed into here as well. So our shuffle duration, what we want to do is get our attack release. So every time we hit trigger, we shrink it down a bit. Now, we don't want it to just immediately pop on and pop off. So we're going to say our attack will happen at 1/4 of this duration. So 1. So 1/4 of a second in will be at full attack. So it'll be the smallest it gets. And then it will slowly feed itself back out over half the length of the motion. So what we're doing here is basically running in the attack release trigger coming directly off of shuffle tiles. And we're doing our duration, basically our attack and release times based on how long we've set that. Furthermore, down here, we actually want to make this a negative value. So we are coming in and saying, we're taking the input from our shrink amount, which is negative 0.25. And we are multiplying that by a float of our Boolean up here. And the reason we do that is every time we click this trigger, we don't want everything to shrink down. It's currently, looks like I can see it's currently doing it for the circle, so I will have to fix that. But again, when we turn it back onto on, you'll see the tiles will shrink. That's running into a multiply node, and then we're just doing an adding 1. So it's always going to be a value of 1 for the scale, and then we're just multiplying that out each time. We're just subtracting from it. And that comes up into our scale up here. So that scale there, so all of our tiles are scaled each time we press the trigger in based off of the shrink amount and for however long we do it. Now, as I said before, we have a round edges rectangle. What we're doing is we're grabbing off of this attack release down the bottom here. And we're saying we've got a little gate going on. And this gate says whenever the round tiles are true, the button is on, and this attack release is happening. So whenever we've pressed trigger, we are going to, you can ignore the multiply by 2 here, but all that's doing is just giving us a larger value. And inside of the rectangle shape modifier, there is a round option. So at the moment, it's default to 0, which means we have harsh edges. But if we trigger now, you'll see that I'll have to make this longer so we can get it going. So shuffle duration. You'll see it actually comes all the way to 1 and then slowly comes back down. If we don't have this multiply by 2 in there, it reaches that 1 value really quickly. So let's just do this by 1 here. It reaches that 1 value really quickly, so it just touches being a circle and then comes back in. But by doing it as a 2, we get the circle. It stays a circle for a good half of the transition and then comes back in nice and smoothly. Alrighty, so besides the fact I need to add another gate in here so it stops the circles from popping in, What we have as a complete overview again, so zooming all the way out as a long overview, we have our input texture coming in. We have a grid that is dividing things up. We are setting the number of grid functions here as well as inside our grid. We're getting the dimensions of each individual tile. We're setting an individual tile position based off of our grid directly. We are then doing a shuffle operation based off the number of instances. That is running into a new transform up here. So we're moving the tiles around to a new position via a smooth. So it's smoothing out, and then we're sending that out into our texture out. And what that allows us to do in the final part here is hitting trigger and reshuffling our image. When we turn it off, it'll unshuffle itself and return back to what we had initially. Alrighty, this is probably a little bit long-winded. It's probably not the best version of explaining I can do for this. I might try and get an actual from scratch build video out soon, but I just wanted to get an overview of this because I thought it was really cool. And I hope it helps you in one of your projects that are coming up. Cheers. Have a good one.